to mention about the Refashion Hub. It's an initiative by Purpose Climate Lab to bring together a collective of multiple stakeholders to address the issue of wastewater in the apparel and textile sector. So we are very glad to be working with them on this particular issue. And we know that there is an imperative need for the apparel and textile sector to address its environmental footprint. And sustainable water management is an urgent need of the hour anyways. Wastewater management, an important aspect for the industry's consideration. In fact, we had a conversation before this, on looking at wastewater and how it's an issue which is not sector specific. It's a conversation that needs to be had by everyone, and how there is a need to relook at our attitudes and mindsets and consider that wastewater is actually a resource and stop calling it waste anymore. It is definitely a multi-stakeholder collaboration and change in mindset that is required. But when we talk about wastewater management, there are so many aspects to it, right? We look at policy, we look at industry action, and we also look at what is technology. Do we have feasible and affordable technologies that is available out there for the industry to use? And we are glad to share that this is the conversation that we will highlight today. We are joined by Karan from Fashion for Good, who will moderate this discussion with Fiddle, an innovator, and Dr. K. Ramesh, who has an illustrious career in this field. So without further ado, I would like to introduce Karan, who will take this conversation forward. Karan is a program manager with the South Asia program at Fashion for Good. He leads the design and management of the innovation program and looks after overall portfolio support. He supports sustainable fashion tech entrepreneurs in their journey to scale within the industry. So Karan, over to you.
Thank you, Devyani. And I guess really the CRB team and Purpose Climate Lab as well for organizing a discussion around this topic. So Fashion for Good is really a global initiative to make all fashion good. It's in the name. And with our innovation platform, we bring on board some of the world's sort of largest brands and manufacturers together with innovations in order to drive circularity. And the wastewater segment, specifically for us, is really exciting because you have all these sort of new developments and the fundamental treatment steps like the primary, tertiary, secondary, and so on, and really exciting new work happening in the zero liquid discharge space and hybrid sort of end-to-end or one-step solutions. But really actually transitioning to a circular model for these brands and manufacturers is really complex because different players use these different technologies and different treatment systems in multiple steps. And these technologies that work within these systems either need to be sort of switched out or plugged in for the overall model to work better. So very interesting space and topic, which is why I'm happy to have two brilliant speakers with us today. And the discussion being really centered around the challenges and opportunities for new technology in this space. So we're joined by Dr. Ramesh, a senior manager at the Tamil Nadu Water Investment Company Limited, which is a public-private partnership led by the government of Tamil Nadu, which is responsible for the engineering of zero liquid discharge-based treatment plants. He also holds a PhD in wastewater engineering with a specialization in textile wastewater treatment and has over 24 years of experience in wastewater treatment as a process engineer. We also have with us Dr. Fidal Kumar, who is the founder and chief technical officer at JSP Enviro, a company that provides sustainable wastewater treatment solutions. Fidal holds a PhD in biotechnology from IIT Madras and has experience in surface chemistry, nanotechnology, product design and development. And with that, I think we can begin. So what I'd really like to start with is probably really understanding the technology that's operating in the space. And Fidal, maybe you could start with sort of a brief primer on JSP Enviro and what you do.
Yeah. So good morning, Karan. Thanks for giving me this platform to speak. So my company JSP Enviro, we are primarily into environmental solution, but in particularly in environmental solution, we are focusing more on the industrial effluent treatment, be it for any industries. So some of the primary targets that we have gone for is textile, the first one, and later we'll be focusing on effluents from dairy and tannery. So based on our common observations, some of the conventional technologies have been going on for some time. For example, activated sludge, reverse osmosis. So it has been going on for quite a few years. And although there has been some innovation in this existing technology, but there has not been a breakthrough different technology that has come out in the recent years. And that's where what we are trying to do over here. So what we are doing in JSP Enviro is, I'm sorry, there's a background. So what we are trying to do in JSP Endeavor currently is that we have came up with a new technology called as microbial fuel cell, which primarily focuses on an energy efficient treatment of the water, which doesn't require a lot of energy input, and it's carried out in a green way as it's done by completely by the bacteria. This is sort out as a replacement for the existing system of activated sludge, and another technology that we are working on is an sort of a replacement for reverse osmosis, which is capacitive deionization, which is supposed to bring down the operating cost for both these technologies. So that is what we are working on here. So this was a brief gist about what we do in JSP.
Thank you, Fidel, for that. I just want to check if we also have Dr. Ramesh on the call. So I mean, Fidel, you talked about treating sort of effluent waste with microbial treatment and all. It's really cool. And maybe you could also sort of shed some light on your on the other sort of wider technologies within the space, because you also mentioned about the reverse osmosis sort of replacements that you're coming up with. And what does that space really look like at the moment? And maybe when Dr. Ramesh joins back, he could also add in.
As I said, many of these technologies has been running over decades. Like it's been adopted over decades, and it's not. There's no issues with the efficiencies of these technologies. Some of these technologies, like reverse osmosis and activated sludge, are pretty efficient when it comes to their working. The only issue with this technologies is the operating cost. So it requires a lot of input of energy for just operation. Capital cost is the common for any technology because it basically involves the same material for building, but the operating cost is what makes the difference, because if you consider the shelf life for a technology for over the period of 10 years, and if there is a constant operating cost for the period of 10 years, it adds up to a very huge amount, for especially for the industries which treat regularly some amount of water. So activated sludge is one of the primary technology to bring down the chemical oxygen demand. So one of the major parameter that is sought out in the water. And reverse osmosis is another technology that has been well established, and there is constant improvement in this. And this is sought out for bringing down the total dissolved solids of the water. So these are the primarily two technology that has been given a huge focus on. Now, when it comes to textile, there is an additional technology that is used because of the zero liquid discharge policy, which is the evaporator. So it's sort out that 30% of the actual cost of the water treatment is because of the evaporation of the water, because rather than energy here, they literally use coal or the firewood to burn out the existing water, which cannot be treated, which is called as the RO reject. So these are the conventional technologies that has been used all this while in this past 10 years, which is very well established.
Okay. And I think you did touch a bit on the economics of some of these solutions. And I think what I want to understand a bit more is, what is a typical customer for these kind of technologies? Have they been scaled to you look at bigger units, or are they all sort of very small scale at the current moment?
So most of these technologies are economical when it comes in the scaling up. So especially when if you are talking about a large scale treatment plant, it becomes much more economical to have this kind of technologies. But if you are looking at a small scale units, like small scale dye units, this becomes expensive because the cost of the capital cost itself is very high. So for example, RO membranes are very expensive. Which you might not need for a small scale, at a large scale, I mean, at that volume, but it becomes expensive when you consider the capital cost. The second thing about this thing is, it's when it comes to a large scale industry, it seems logical that a few of the industries come up and put up a common effluent treatment plant with all this technology, because till some time back there was a huge amount of subsidy that was given by government to establish such plants. But that is not the case with small scale units. So it becomes much more expensive for them if they have to set up a wholesome zero liquid discharge plant for them. So that is where the economics differ for a small scale and a large scale industry. I'm pretty sure Dr. Ramesh might be having a much more experience while dealing with the CETPs. But what I'm talking about is from the perspective of small scale unit and IETPs. Okay. And this is pertaining to the textile specifically, but because in textile there is everything, because they use a lot of dyes, and they also use a lot of salts to fix the dyes. It contributes to both COD and TDS. But if you consider something like dairy, they might not have a large amount of salt. So reverse osmosis might not be so much necessary. For them, a simple activated sludge or MBBR will be much more useful than installing a reverse osmosis. So that's where the cost for the textile effluent treatment and the cost of other industry differs. Yeah.
Thank you. And I think the area around the energy used for these solutions is also somewhat of a challenge. And I think one of your solutions has looked at sort of refurbishing some of that energy back into the system. And just around your thoughts on that is something I want to understand a bit as well.
Yeah, so as I mentioned previously, the major of the cost that is involved in the treatment comes from the energy of the operation. So for example, activated sludge requires a huge amount of diffusers to aerate the system. Similarly, reverse osmosis requires a large high capacity pumps to pump through this membrane. So most of these, other than the capital cost, the operating cost comes from literal input of the electricity. So what we are trying to do is we are trying to enrich some kind of bacteria or microbes which can harness this energy in the form of electricity and give it back to the system. So what our company is trying to innovate is to make an integrated system whereby the activated sludge is replaced by the microbial fuel cell, and whatever the energy is produced by the microbial fuel cell can be pumped into the second system, that is capacitive deionization, to remove the TDS. So overall, it will become energy neutral compared to the energy demanding system of reverse osmosis and activated sludge. So that is the innovation that we are trying to do at this point.
Super cool, I think. And on the, I think really extending on the economics front, like the when you're, and we talked about customers already, but when you're trying to sort of engage these SMEs or even these customers in general, what are some of those challenges when really trying to work with a manufacturer brand? Like, is that a plug and play solution? Is that easy? Is it a long process? What does that look like?
So that is a challenging aspect. So there are two points involved over here. So some of them are readily, open to accepting a new technology, but the problem is we might not be capable of operating at that scale. For example, there are companies which produce like 10 mld. Of course, my technology, we have not reached that scale to work at 10 mld. Whereas if you consider SMEs who are already, trying to cut down their cost, in the water treatment or bring down their overhead cost, they are not so much open to a new technology because they don't know whether it will work or not. So they want to see an existing model which is working. And even if it is working, what they are looking into is they have an existing system. Can you modify that system to the new existing technology so that they don't have to spend a lot on the capex of the solution? So it's a double edge. So for us, the challenging aspect is to find a right fit of the client who are not operating at such a high scale that we don't have to worry about something which we are capable of handling. At the same time, someone who is also open to the challenges associated with the new technology. The challenges might be the initial few bumps that might be involved in the operation, or some amount of extra expenditure. So who is ready to test it out with us, this new technology when it's coming to the market.
Right. And I mean the need for such a partner, I think, does that also sort of bring, like, are there other sort of partners where you feel is really needed in the space in terms of funding, in terms of other support? What do you really think is needed for some of these solutions to do better?
So
Tough question, I know, I'm sorry. But yeah.
So when it comes to funding, so there are existing government technologies, government agencies which are ready to fund the new technologies. For example, one of the things that we have got into is BIRAC, which is operated by the government of India, and they are ready to give some initial startup grant for to begin with, to test out the technology. So the whole idea of some of this government grant is to test out a new technology, whether it works or not. So the kind of investment they usually do is into a high risk technology. So only those government agencies can take that risk of such a high amount of failures. So that's the reason that this kind of fundings exist. So there are plenty of grants, like one of them, as I said, is BIRAC, and within BIRAC there are different schemes. So for example, when you go from prototype to the pilot stage, they have a higher level of funding. So, but the problem is over here, such kind of grants are very limited. and so there needs to be much more, more specialized grant when it comes to the water treatment technology phase. If there is some specialized grant available, that will help us a lot. Like innovators like us, like it will be very useful. So, for example, when you said, say, BIRAC, they are looking into different fields, starting from medical, industrial, and so on. And they have some limited seats, seats for which they can provide the seed funding for. But there is nothing specialized grants available for the water. So, if there is some space available over there, that will be really useful for us.
All right. I think that does give us a bit more of an understanding. And I think following up on earlier bit, and also when you mentioned about the whole risk around this space, and also the idea that the small scale technology is just really more expensive. What does that look for in terms of like the future of trying to service SMEs? If we wanted to sort of work with smaller scale players, what are the unique challenges involved, and how can we actually get to a place where that's possible?
So one of the things that I find might be very lucrative is providing again the subsidy, especially for SMEs, not just the CETPs. So example is, for example, government is giving subsidy for adopting electric scooter. So although electric scooter is expensive, people are still trying to adopt it because there is a certain amount of subsidy that is given for the each scooter that is sold. So if there is some kind of lucrative subsidy that is available for adopting the new technology, that will be really useful. Right now, the only policy that is available in space is zero liquid discharge, and that is very mandatory, especially in South. So for them, they need to have a technology that works, particular way to that policy for adopting that policy, zero liquid discharge. But there is nothing available for adopting a new technology. So if there is some kind of incentive that is given to these SMEs or the new players for adopting a new technology, that will be much, much useful for innovators like us.
Right. I think that makes a lot of sense as well. And you did mention about this policy aspect and how that would work with SMEs. In terms of a broader sort of coordinated kind of policy around this space, because you've also mentioned finances, specific funding that's needed for the sector, as well as on the other hand, on the other side, really working with customers and suppliers. And is there anything you'd like to add on the policy aspect that something could really work as a more coordinated scheme?
Uh, so, uh, one thing, it might not be my area, but I think Dr. Ramesh might be able to elaborate much better in this. But if there is some kind of energy credits that is given to the SMEs for adopting a green technology. So right now, how the zero liquid discharge work is like an enforcement. Okay, either you adopt it or there will be raids and the companies will be shut down and stuff like that. But if there is some kind of energy credits that is given for the technology, for the SMEs for adopting the greener technology, I think that might be one of the lucrative way for them to attract new technologies and testing out in their space. So that is what I used to think all the time. I'm not sure how difficult it is in the policy view, or it is in the form of a governance or bureaucracy view. But just as a point of view from the innovator, I feel that might be really useful. And second thing is, other than these green energy credits, if there is some subsidies that is given just for the adopting the technology, that also might be very useful for. So these are the only 2 points that comes to my mind.
No, definitely. I think just hearing from what like what an innovator would need in this space is really important, and you sort of have to balance all the stakeholders in looking at solution. Um, so I think Dr. Ramesh has not been able to join us because of a few technical issues. So I think we will be sort of closing early. But I think Fidel, I'd want to hear just a bit of like maybe a closing statement from you, because we've discussed some of these challenges. We've talked about why the sector of water treatment really needs to be holistic. So not just on effluent treatment, but also looking at dyeing processes and the chemicals that are involved in that space. And also we've talked about why these small scale technologies in this area are really expensive, because not just of the capital cost and the energy involved, but also the maintenance of that system end to end. And when we try to explore solutions, I think we did look at specific finances to be sort of allocated to the space, as well as subsidies on the customer side. So really working with SMEs and the sector to kind of enable that to happen. And we've also touched a bit on innovative sort of instruments, like we could look at energy credits and so on and so forth. And we really do need more technical people in this space. I'm really happy to see Fidel here, who's from our last batch. And I think maybe, Fidel, if you just want to wrap up as to a couple of lines as to what on our discussion today and anything else you'd like to add.
Yeah. So as far as in the recent trends with when it comes to grants and how the startups are evolving in India, what personally I feel is it's not as bad as how it used to be 10 years before. There is certainly a lot of organizations like yourself in FFG, who help us, connecting with the right people for testing be innovators to test our technology. What we would also like to see is some more an open-mindedness with the SMEs who can afford it to test a new technology. That even as you consider any new technology, it is bound to certain amount of failures. But if there is a little bit of openness to just test it out how it is, it will be really useful to take this water treatment into whole different levels. So that is one thing, and otherwise I feel there is a lot of progress that is happening both in commercial as well as in the technological front, and I feel in the coming years it will be much more visible.
All right. So it's really sort of a mindset shift all across, I think, that's needed. And thank you. That was beautiful. And I'd like to also thank the CRB team for having me and for having Fidel here as well for sharing the thoughts. Thank you so much. I'll pass it to Devyani now to sort of close the session.
Yeah. Thank you, Karan. Thank you, Fidel. I think that was very enlightening. It was short and sweet. It's unfortunate that Dr. Ramesh was not able to join us, but I think within these 20 minutes and what was important, and Karan has summarized them beautifully, that we touched on all the right things, that this is multi-stakeholder. It is not a conversation at a particular node, right? Because he brought in the issue of chemicals and the whole dyeing process and not just looking at water as a standalone. And also, I think what I hear is also a need for a lot more awareness, because you talk about the mindset change, and with the SME, somebody having to take that risk with them. So we have to figure out which is the best player to take that risk of new technologies and really start this journey. But yes, good to know. It is really informative, and I think it's given us food for thought also, because there are some very clear asks from a policy front, right? That there are some grants, maybe how can we link them better? How can we make them more specific? Can we carve out a niche perhaps for the water space? And how do we look at SME specifically? Because within the SME sector also, we know that the small and medium and micro are so different that you can't look at like one bucket of, one combined incentive for them, that you may have to break that incentive as per their scale also. So I think this has been very, very helpful. And thank you both for taking the time to have this conversation and to make it relatable for the people who've joined us for this conversation, that it is not a very difficult conversation. There is innovation happening. It requires a mindset change, and it requires us to really keep having this conversation. So thank you so much. And this conversation, we are looking for another series. Fidel, you've given us an idea that we should perhaps now speak to the chemical sector players also, who are also looking at this, and can we have that as perhaps one of our conversations. And I just wanted to let everyone know that these conversations are available on our website if you want to go back, listen to them. And we'd be happy also to take any questions that people have. They can reach out to us and we can get answers back to them. So thank you so much. Have a lovely day.
Thank you so much, Devyani.
Thank you.